In this question, by using this data, I am explaining the part D question. Here, if G circle of composite function is onto, we are going to prove G is onto function. So, given that the function f is a domain A and codomain B. Function G is having the domain B and domain C. So keep in our mind, so A set elements we can represent with always we can represent with the X element, B set elements we can represent with the Y element, C set elements you can represent with the Z element. Keep in mind. Now coming to the our condition, what is given? G circle f is onto function is given. Then how can you form this composite function domain and codomain? We know that domain of the G circle f composite function, any composite function, the second set domain, that is the value. Second set f is f domain is A, you write that the A is the same domain for the composite function. What is the codomain for the composite function? G codomain. G codomain is C. That's why this is the codomain for the G circle f function. Okay. He is given that G circle f is onto function. Then now we can say that each element in the A having the images, okay, each element in the A having the images in the set C. That is the meaning. So we can represent that X, you can take the A set elements, we can represent the X only na. You take the X belongs to A and C set elements you can take the Z belongs to C. Now I can write it, because of onto function only I can write this condition. Okay. So A set elements having the images in the set B, set C, that which is represented by Z element. Okay. Now I can rewrite again this composite function, this circle I am removing and plugging in the bracket for the function f of x. Okay na? So when we simplify, first we can do that f of x. We know that g of something you are getting the output values, means compulsory there is some x values, so there is some x values, compulsory f of x is having the images compulsory. Okay, so the f of x is nothing but x images. Okay, if x belongs to A set, compulsory f of x is also getting the images which is belongs to the B set. Okay, we know the corresponding for every x input there is a corresponding images are forming in the set B. That's why we can write the according to that one set B elements I can represent with the y element. I can write that y is equal to f of x. I can write it now because of I don't know for some x belongs to A, compulsory there exist a image values in the set B. Compulsory there is a image values in the set B. Then we know that in set B elements we can represent with the y element. That's why these images we can equate to the y element. Now see the above step. This f of x we can replace with the y. Now see g of y is equals to z. So this is only, then we can write we can say that g is the onto function because of this condition. What is that meaning? Y is nothing but y is belongs to the B, here z is belongs to C, then g function is nothing but g function is B to C, which is every element in the B set which is having the corresponding images in the set C. So there is no empty element. Okay, now all are the images which can form from the set B. That is the only meaning. So in this way we can prove it. So how did we prove the g onto function? Some g of input value, here g input value is the B. Okay na? B set. So for every B set there is a corresponding image value. That's why we can say this is the